British Brown Bess, adopted under wartime pressure in 1793 and drawn from East India Company stocks. The India pattern became the British Army's principal flintlock through the Revolutionary and Napoleonic Wars. The Board of Ordnance formalized the pattern by 1797, issuing it to line infantry, militia, and colonial regiments from Europe to India. It armed the bulk of Wellington's troops at Waterloo in 1815. The standard arm was a .729 to .76 caliber smoothbore flintlock with a 39-inch barrel, 3 ramrod pipes, and plain walnut stocking. Furniture was brass, simplified for speed, and the lock progressed from a swan neck cock on early 1793 assemblies to a ring neck form by 1810. Practical accuracy clustered around 40 to 60 meters. Service loads could deliver lethal energy beyond that, but British training emphasized controlled volleys rather than individual marksmanship. Production centered on the Birmingham trade under ordnance contracts with government proofing. Early shortfalls were bridged by East India Company inventories and liege purchases. In drill, 3 rounds per minute was a realistic expectation. British powder quality and cartridge manufacture yielded consistent ignition. A standard socket bayonet brought overall length to about 73 inches, key to line tactics that combined close-range volleys with decisive advances. Variants included the 1793 and 1810 lock styles, militia and company sub-patterns, and later percussion conversions for training or colonial service. The India pattern closed the British flintlock era with a design that also previewed later mass production approaches. French Charleville. The Charleville family emerged from France's push for standardization that began with the Model 1717 and matured through the 1728 and 1763 patterns. The Model 1766 refined that process, becoming an influential export during the American Revolutionary War and laying groundwork for the Revolutionary and Napoleonic armies that followed. Production spanned several royal armories, Charleville-Mézières foremost, with Saint-Étienne, Toul, and Maubeuge contributing, creating a statewide system able to arm mass conscript forces. Development emphasized lighter weight, improved balance, and more consistent fit than earlier muskets. The 1766 prefigured the 3-band system that would become synonymous with later French patterns and inspired America's first standardized musket. Springfield Model 1795, which borrowed its geometry and lock concept directly. Typical examples were .69 caliber smoothbores with 44 to 46-inch barrels, walnut stocks, iron fittings, and a steel ramrod. Manufacture relied on multiple state factories and, during wartime, contracted workshops that sustained volume through periods of upheaval. In service, the musket yielded 3 to 4 rounds per minute in trained hands. Formation effectiveness extended to about 200 yards against massed targets, with individual fire far closer. Flints wore quickly, and fouling after prolonged action demanded frequent maintenance. Yet soldiers valued the musket's livelier handling compared to British contemporaries. French Model 1777. The Model 1777 codified lessons from the 1763 and 1766 muskets and became the principal firearm of the Revolutionary and Napoleonic armies. It armed French forces across Europe and, through capture or transfer, equipped allied states such as the Kingdom of Italy and the Duchy of Warsaw. Refinement rather than reinvention defined its evolution. The 1777 inherited the handier proportions of the 1766 but tightened tolerances and standardized components. Experience soon revealed fouling issues and maintenance snags. The Courage and Nine-End revision in 1800 addressed these with an improved lock, simplified bands, and sturdier stock geometry. The pattern's proportions influenced Prussian and Austrian muskets in the early 19th century. Standard chambering remained .69 caliber. Typical barrels ran just under 45 inches. With iron bands and furniture, a front sight integrated into the upper band, and a flintlock that many arsenals later converted to percussion. The tighter ball and charge combination marginally improved accuracy at the cost of faster fouling during sustained fire. Production was massively expanded during the wars, with wartime exigencies leaving finish quality and interchangeability variable. In drill conditions, 2 to 3 rounds per minute were sustainable in combat, up to 4 on the parade ground. Effective ranges overlapped those of British muskets, yet French training leaned into rapid and uncoordinated volleys rather than independent fire. A robust triangular socket bayonet locked more securely than earlier fittings, supporting aggressive assault doctrine. Service continued in post-war evolutions such as the 1816 and 1822, with widespread percussion conversions extending life. The Model 1777s reach both literal and conceptual-shaped European small arms far beyond the Empire's collapse. Russian Model 1808. The Model 1808 represented Russia's move toward uniform small arms issue at the height of Napoleonic pressure. It replaced a patchwork of older domestic muskets and imported or captured arms, becoming the principal weapon of the Patriotic War of 1812. Line infantry and militia formations received it in the campaigns that rolled from the defense of Moscow to the advance into Central Europe. Its design drew on earlier Russian patterns from 1798 and 1805, each influenced in turn by Prussian and French practice. Russian requirements drove the silhouette toward durability rather than refinement, better suiting harsh weather and the realities of long supply lines. A typical 1808 was a flintlock smoothbore around .70 caliber, the Russian 7-line bore carrying a 42-inch barrel and minimal sights. Stocks were walnut or birch, furniture and bands iron or brass depending on materials on hand, and the lock used a reinforced cock and frizzen to improve performance in damp conditions. The overall package was long enough for bayonet work and robust enough for indifferent maintenance in the field. Production centered at Tula Imperial Armory, with Izhevsk expanding after 1810 and private makers supplying parts or complete guns under contract. The state pressed for thousands of muskets per month, yet shortages persisted given army size and battlefield attrition. On the line, trained soldiers could maintain 2 to 3 rounds per minute. Reports praised the musket's sturdiness and resistance to breakage and fouling, even as troops noted heavier weight and coarser finish compared with captured French arms. A triangular socket bayonet locked to a muzzle lug, with tactics stressing volley fire and shock action in massed formations. The 1808 family encompassed infantry, dragoon, and artillery lengths, and many examples were later converted to percussion. The pattern remained in service until superseded by new percussion series in the 1820s and 1840s, and it helped anchor Izhevsk's rise into a mainstay of Russian weapon production. British Royal Navy Sea Service Musket. The Sea Service musket evolved under Admiralty direction from mid-18th century requirements, equipping seamen and the Royal Marines through the American Revolution, the Napoleonic Wars, and the War of 1812, designed for shipboard conditions and the reality of fighting both afloat and ashore. It became the compact counterpart to land service arms. Its lineage runs within the Brown Bess family but diverges in 3 persistent naval traits: a shorter barrel for maneuvering in cramped spaces, 2 ramrod pipes instead of 3 or 4, and a distinctive flat square corner butt plate. Caliber typically stayed near .75. Late examples are documented with barrels around 37 inches, and fittings remained utilitarian small trigger guard, flat steel butt plate, and no brass nose cap. Finishes split by Royal Marines often carried bright arms in line with infantry presentation, while seamen received blackened or japanned surfaces to resist salt corrosion. Manufacture used a mix of government arsenal work and contracted workshops under Admiralty oversight. In action, rate of fire matched contemporary flintlocks 2 to 4 rounds per minute for trained detachments. A socket bayonet remained central, the short barrel lending itself to close-quarters thrusting where space was scarce. Marine and seaman variants differed primarily in finish rather than mechanics, and surviving pieces sometimes saw percussion conversion later in the 19th century. The Sea Service musket distilled naval requirements into a durable pattern that informed later Victorian naval small arms. Spanish model, 1752. The Model 1752 marked Spain's first fully standardized long gun, an empire-wide service musket that remained in use through the Napoleonic period and beyond. It armed Spanish line infantry in the Peninsular War and circulated across colonial theaters, with shipments of roughly 10 to 12,000 sent to the American rebels during the Revolutionary War. Conventional in layout but distinctive in mechanics, the 1752 employed the Spanish Micalet lock. This regional lockwork rearranged mainspring and hammer geometry compared with the flank-style locks of France and Britain, while preserving flint ignition. Specifications from the provided material list: a .69 caliber bore, an overall length of 57.09 inches with a 43.31-inch barrel, and a mass of about 10.8 pounds. Two brass bands and a nose cap secure the barrel to the stock. A steel ramrod sits in a channel beneath, and the front sight is cast into the upper band. Undersized balls were used deliberately to ease loading as fouling built up during extended firing. The pattern was built at state arsenals, distributed widely throughout Spanish holdings, and exported to client forces. Mid-19th century conversions to percussion were common as armies updated ignition systems. Field performance tracked with period expectations 2 to 3 rounds per minute for trained troops and practical volley distances in the several dozen yard range. It endured by evolving through incremental changes and conversions rather than being retired wholesale after 1815. Danish-Norwegian Kyle. Designed by C.W. Kyle and produced at Copenhagen Arsenal, the Model 1794 modernized Denmark-Norway's infantry arm before the Napoleonic conflagration fully arrived. It served through the Anglo-Danish conflicts and the Gunboat War and equipped both regulars and militia, including the Royal Life Guard and Norwegian Line Infantry. A shortened Model 1808 answered the need to issue arms to shorter soldiers, with limited distribution into Norwegian units during the 1808-1809 campaigns against Sweden. Kyle's work paralleled French and British trends, but added distinctive northern solutions. The musket incorporated a conical touch hole that fed priming powder automatically, effectively self-priming the pan. A vertical pan shield addressed the hazard of 3-rank volley fire by protecting the face of the man to the right. A spring-loaded bayonet catch sped mounting and removal, and sliders secured the barrel in lieu of pins, simplifying maintenance. Later, 1807 and 1808 versions used an internal lock arrangement that improved water resistance, a practical advantage in a damp climate. The family remained a smoothbore flintlock around .75.80 caliber, with barrels near 105 centimeters in the 1794. Production was centralized at Copenhagen, with about 50,000 Model 1794S and roughly 30,000 simplified Model 1807S reported. Reports and later reconstructions describe a fast-firing, durable musket that resisted bad weather better than many contemporaries, at the cost of noticeable weight on long marches. Doctrine matched wider European practice linear volleys with quick access to bayonet fighting, while Grenadier and Jaeger companies performed skirmishing tasks using the same core weapon. Post-Napoleonic life extended through percussion conversions and pillar breech adaptations in the 1840s and 1850s, with Kongsberg Wapenfabrik handling much of the work. The Kyle family marked a clear shift from ornate 18th-century muskets to functional, field-oriented Scandinavian arms. Swedish Model 1815. The Model 1815 emerged in the rearmament that followed Sweden's 1808-1809 war with Russia and the loss of Finland. Sweden had sold large numbers of arms to Russia before the conflict, leaving arsenals thinned. The 1815 joined the earlier 1811 pattern to rebuild stocks. After the 1814 union with Norway, it became the standard infantry musket for the combined forces and later served as a baseline for Norway's first post-independence pattern of 1825. Design influences ran through French channels. The 1811 and 1815 reflected lessons from the Charleville 1777 and year 9th era, and Sweden reduced bore size to 18.55 mm, 73 caliber in line with continental trends for ammunition standardization and recoil management. Typical construction included a smoothbore flintlock barrel of about 42-44 inches, 3 bands, an iron ramrod, and either iron or brass flashpans depending on the precise year. Manufacture relied on state factories with component standardization, an area where Sweden's high-quality iron industry contributed consistent inputs. After Union, Swedish production helped replenish Norwegian inventories. Over time, the pattern saw practical updates, a switch from iron to brass pans in 1820 and back to iron in 1822, and a dovetailed rear sight introduced in 1838 to enable limited aimed fire. Large numbers converted to percussion beginning in 1845, model 1815-1800, and some later received pillar breech rifling. The pattern spans the transitional era from late flintlock to early percussion in Scandinavia and leads toward the later adoption of breech loaders such as the Kammerlader and, eventually, the joint Swedish-Norwegian move to Remington rolling blocks in 1867. Prussian model 1809. Potsdam. The model 1809 sits within a Potsdam lineage that began with the 1723 and 1740 patterns and became the Prussian Army's standard smoothbore during the Napoleonic period. By 1815, it was the most common musket in Blücher's army at Waterloo. Assembly and finishing took place at the Potsdam Arsenal. Drawing barrels from Spandau and integrating cost-saving measures introduced during wartime mobilization. French influence is unmistakable. The 1809 borrowed heavily from the Charleville 1777 in overall architecture. Yet Prussia changed details to speed production and reduce expense. Pins gave way to 3 steel barrel bands, and the bore was reduced to .71 caliber to standardize ammunition while preserving the ability to digest larger captured cartridges in a pinch. Manufacture split tasks between Spandau, the barrels, and Potsdam, the assembly, with wartime output rising from about 55,000 by 1813 to roughly 65,000 by 1815. Trained infantry could expect 3 to 4 rounds per minute. Practical accuracy stayed within 100 yards. Doctrine, as elsewhere. Focused fire at closer ranges. The .71 bore allowed some flexibility with battlefield scrounging of ammunition, though firing undersized balls degraded precision. A Charleville pattern triangular socket bayonet around 19 inches locked to the lug, supporting line infantry tactics of volley fire and rapid transition to close combat. Its prominence at Waterloo marks the pattern's operational peak. French Toul Fusil. The Toul musket line arose at the Royal Armoury of Toul around the turn of the 18th century, beginning as civilian fusils de chasse and evolving into naval and select army issues. By the Napoleonic period, earlier Toul guns often lived second lives with reserves, militia, or private owners. They still turned up in colonial theaters and irregular formations such as in the Caribbean and North America. Design heritage places Toul before standardized Charleville patterns. It shaped and was ultimately superseded by the 1717 push toward state uniformity. The family intersects with French trade and diplomacy in North America, where fusils de traite reached indigenous partners, and it parallels English trade guns while favoring smoother lines and lighter barrels. Saxony's 1729 Soule pattern is noted as a direct copy adjusted to local needs. Mechanically, these were flintlock smoothbores. Early fusils ran near .62 caliber for hunting use and later drifted toward .69 for naval and military service. Barrels of roughly 44-47 inches were pinned to stocks rather than banded on earlier builds. A distinctive cow's foot buttstock shifted balance and mitigated recoil. ramrods transitioned from wood to steel, and bayonets evolved from early plug types that precluded firing to later socket fittings that allowed both shooting and thrusting. Tool's output included bespoke and contract batches and fed colonial exports through the fusil de traite. On the range and deck, trained shooters could manage 3 to 4 shots per minute. The guns felt lighter and handier than later standardized line muskets, though sustained fire exposed fouling limitations in the slimmer barrels. Variants span the fusil de chasse, fusil de marine ordinaire, fusil de grenadier, fusil de traite, and officers' models. The Saxon Sewell copy rounds out the family's spread. National-level flint-to-percussion conversion programs after 1815 did not focus on these older fusils, and many retired as newer patterns filled arsenals. The Tula lineage, however, shaped the conversation